Hello, and welcome. Today I am going to show you the corrugated-specific ERP software built on Microsoft Dynamics 365 Finance and Operations, developed by Samadhan. This is a solution designed around the way a corrugated box plant actually works, and I will take you through the whole of it, from the initial master setup all the way through to a design that is ready for production. We will begin with the setups the system needs. This is the PDI general setup, covering length, width, and height, board length, box dimensions, and the deckles. Next is the trim setup. Here you define the ply-wise left and right trim and the total trim. This is what allows the system to calculate the standard trim and the trim quantity automatically, rather than leaving it to somebody's judgment on the day. Then we have the setup for the Deckle master. These deckles are what drive the PDI itself. PDI stands for Product Design Interface. It uses these deckles to choose the best deckle size for a given board length and width. And best here has a very specific meaning. It is the size that produces the least wastage. In this industry, wastage is exactly where your margin quietly disappears. Then there is the machine setup. Here you define each machine, its maximum width, and its number of ups. That maximum width is a real physical constraint on your shop floor, and capturing it here means the system will never propose a design your plant cannot actually run. Next comes the OD to ID conversion and the manufacturing joint setup, where you define the flute type and the ply-wise margins for length, width, and height. This is what lets the system calculate the ID to OD conversion automatically. That calculation applies to the final finished goods item. Then there is the pin gap setup, which is used for stitching. It determines how many pins are required based on the box dimensions, so the stitching specification comes out of the design rather than being decided at the machine. Then the board grade master. A board grade is simply a combination of papers, bringing together the top liner, the fluting, and the bottom liners into one defined, reusable grade. After that comes the model master, which holds the FEFCO model codes, the international standard for box styles. Then the take-up factor and height. This is the flute-wise take-up factor and height. It matters a great deal, because the entire calculation of paper consumption is built on top of these figures. Then the GSM, BF, and RCT master. And the corrugation scorer position setup. Now these are the board calculation details. When you create a pre-sales PDI, or when you raise a quotation and create the PDI from it, this is where the board calculation actually happens. Everything you have just watched being configured feeds into this single point, and that is why the setup work is worth doing properly. Get the masters right, and every quotation afterwards inherits that accuracy. Then we have the printing scorer position master, the board item master, and the attribute types master. That last one defines the attributes a corrugated box needs in order to be described completely and unambiguously in the system. Now let us move to the pre-sales PDI. This is the pre-sales PDI list. I will open one of them, PDI number 254. You can see the tabs running across the top: general details, finished goods details, subcomponent details, product image, and tooling and development. Let us start with the general detail, which carries the PDI number, the customer, the date, and the customer part number. It also holds the approval-related details. Then this is the finished goods tab. Here you find everything relating to the finished good itself, the FG unit cost, and the price against the expected purchase order quantity. And in the header we define the board grade, which, as we have already seen, is the paper combination together with the routing that will be used to make it. So the commercial figures and the manufacturing definition sit against each other from the very beginning. So let us look at the technical design first. Within the technical design, you have the header, the technical details, the OD details, the ID details, the board calculation details, and the corrugation scorer positions. Each one describes a different layer of the same box. The technical detail covers the box type or model number, the number of joints, the flute, the number of plies, the tuck size, the finished goods length, width and height, and the top and bottom paper. That is the complete physical description of the product. From all of that, the system calculates the standard trim, giving you both the trim weight in kilograms and the trim size. And if you need to add extra trim beyond the standard, you can enter it here, and the system takes it into account immediately. This is precisely the sort of calculation that is slow and error-prone when it is done by hand, and effectively instant once your masters are in place. And because it is derived rather than typed, you get the same answer every time from every estimator. Then we have the identified paper deckle. The system gives you the best deckle size, and by best it means the size that produces the minimum wastage for this particular board. On a high-volume product, that single recommendation can be the difference between a profitable job and a marginal one, and here it is being made automatically on every design, every time. It takes the guesswork out of the one decision that most affects your material cost. This reflects whichever board grade we selected in the header. So you can see the paper combination across the top liner and the fluting. The paper details carry the deckle, the GSM, the BF and RCT values, and the flute quantity in kilograms, shown both with trim and without it. Nothing is hidden or rolled up, so you can see exactly where the material is going. And this is the box calculation detail. That covers the technical side. Now there is one more tab, the converting technical details. Up to this point, we have been discussing the board and the corrugation itself. From here onward, we are talking about converting, which is the printing and finishing side of the process. Everything from this point relates to how the printed surface of the box is produced and costed. And this is the ink detail. You define the printing area percentage and the ink quantity per square meter. Based on that printing area, the system consumes the ink item automatically, which means your ink cost is genuinely calculated rather than estimated from experience. Then we have the die detail, the printing plate detail, and the printing scorer detail. You can also attach an artwork number here, so the design carries its own reference. That keeps the artwork tied to the specification instead of living separately in somebody's folder. That covers the corrugation and converting side. Now we come to the customer requirement. At the quotation stage, a customer will very often have specific requirements. My ECT must be this figure, my BCT must be this, the box weight must be that. All of it can be defined here, attached directly to the design, so the requirement is properly recorded rather than remembered by whoever took the call. When the job reaches production months later, the specification is still exactly what the customer asked for. Some customers want a normal bundle with shrink wrap. Others want bundling with shrink wrap and palletization on top of that. Every one of those variations is managed here in the Customer Requirement tab. Now this is the defined process cost. This exists for any additional process the job happens to need, such as coding or stitching, where a particular machine and a particular cost are involved. You define that extra process here, and its cost flows into the total automatically, instead of being remembered and added on at the end by hand. Any process your plant genuinely performs can be represented, so the costing reflects reality. All of the BOM-related details then appear in the subcomponent product or the finished goods BOM detail. Then you can add the product image if you want the design to carry a visual reference alongside the numbers. And there is a tooling and development charge, so if this particular job requires new development or new tooling, that cost can be entered and properly accounted for. From all of this together, the system produces a full cost summary, beginning with the total raw material cost. This summary is the figure your commercial team ultimately quotes against, so it has to be complete. It shows the total process cost and the total tooling and development charge, and not only the costs themselves, but the percentages behind them. Raw material as a percentage, process overhead as a percentage, and tooling and development as a percentage. That breakdown is what actually tells you where the money in this box is going and where there is room to improve it. Across many jobs, that is the information showing you which products are genuinely worth winning. So you can see the quoted price sitting alongside the true production cost. Then there is one more tab for any other applicable charges. If freight is extra, or there is a packing charge or a third-party charge involved, it is entered here. You add those prices, and the system builds them into the quoted price accordingly. That completes the pre-sales PDI. There is one more thing worth showing you here. If you need to create a new item, you simply flag it as a new item, and the system creates it for you directly from the design you have just built, with no separate item master exercise. The design and the item record are created together, which keeps them permanently consistent. It uses the category you selected for the finished goods item, together with all of the required attributes: flute type, height, joint type, length, width, and so on. And because the item is generated from the master data itself, there is no chance of creating a duplicate, whether by name, by description, or by any combination of attributes. That matters enormously in a plant running thousands of similar box specifications across many customers. Now, once the item is defined and everything is in place, you click Create Pre-Production PDI. So what does Pre-Production PDI actually mean? It is the moment a design that was built to win the business becomes a design the plant will manufacture against. The commercial stage is finished, and the technical stage begins, with all the work carried forward intact. Nothing is re-entered, and nothing is lost in the handover between the two teams. Once the quotation converts into a sales order, the pre-sales PDI converts into the pre-production PDI. Every inquiry item, whether it relates to the finished good or to a subcomponent, is converted into a proper FG item or main item. And all of that information carries across automatically into the production PDI. So let us go into the pre-production PDI now. This is the pre-production PDI document. Inside it, you have the pre-production general tab, the finished goods tab, the subcomponent tab, the product image, and the other component tabs. This is the general tab, which is where the PDI is approved. From here, the technical team can review everything that sales committed to and adjust it wherever the plant needs something different before any of it reaches the shop floor. This review step is what stops an over-optimistic quotation from becoming a production problem. They can change or add the secondary bill of materials. Then there are the converting-related details, the subcomponent BOM items, the product image, and the other costs. And when you click Associate BOM and Route, the system associates the complete bill of materials and the full routing in a single step, without anybody having to build it manually. That one click replaces what would otherwise be a long and error-prone piece of data entry. It attaches all of it to the main finished goods item. At that point, the design is complete and ready for production. That is the corrugated solution from Samadhan, built on Microsoft Dynamics 365. Thank you for watching.